Hello, everyone. Welcome to this presentation on cybersecurity and threat detection for AI and big data analytics. My name is Keith Parker. I'm the Director of Product and Solutions Marketing here at Pavilion. And today we are joined by Keith Ober, our Principal Architect for the Federal Division. And this presentation will be recorded. If you do have any questions, please feel free to enter them into the chat and we will answer them as soon as possible. And with that, let's go ahead and kick this presentation off. So today we're going to go ahead and talk about the importance of cybersecurity and why it's such a critical issue facing organizations today, how the disaggregation of I/O is driving the ability of modern applications to provide threat detection and intrusion prevention, how applications using big data such as Splunk are using high performance object to really manage and store and organize that data so it can be analyzed and utilized for the detection of threats, how hot and warm data scaling impacts that storage, how artificial intelligence and tools for AI and threat virtualization are really impacting what can be done to identify those threats, and how the rise of GPUs and low latency storage are really driving that function. And so with that, let's go ahead and talk about why cyber is so important. Now we've all seen the headlines that have been going on lately with organizations and even governments being attacked by various threats. But just it's something that we all obviously know, so I won't spend a lot of time on this, but I just want to highlight what some of the staggering numbers are that are really driving this. Right now, every minute, $2.9 billion is lost to cybercrime. That's every minute of every day. And companies are paying up to $25 a minute whenever there's a cybersecurity breach. And those breaches tend to take a very long time. In fact, in 2020, the average cost of a data breach was $3.86 million. And that's because it takes so long to find, discover, and close those particular threats. And overall, we're looking at a total cost of cybercrime of $10.5 trillion annually by 2025, which is surprisingly just around the corner. So obviously, cybersecurity is a huge focus for organizations, governments, agencies, really everybody in the modern world. And I'd like to go ahead and introduce Keith. And Keith, would you talk a little bit about how some of the tools that are being utilized to solve this problem are really being limited by the infrastructure that supports it?
Yeah. Thank you, Keith, and thank you, folks, for joining us today. Absolutely, this is cyber tools are limited by the architecture, but obviously a lot of people don't realize just really what's going on in the marketplace. If you look on the right-hand side, that's just a quick landscape of all the tools that are out there within your organization's ability to grab and take advantage of. But what you don't see is really what are the limitations with these designs when you scale them out. Regardless of the tool, there are some other changes happening. Number one, there's massive amounts of data capture happening, whether it's log data, system data, syslog data, all of this data is coming in, and it's only becoming more and more of a bottleneck in the architecture. The other piece of this is CPUs and GPUs are expanding in the amount of horsepower that they have in this environment, but the data path underneath of them really hasn't changed. And I haven't even gotten into bringing about new innovative solutions that are AI models or machine learning models that, again, they're running into this IO intensive type of workflow that are really, people aren't noticing that there's the problem within the environment is less about the applications they're running and more about the way they've architected the data flow. Let's talk more about that maybe on the next slide. And one of the things that you'll notice, I come from a hardware world. I spent a lot of time in the federal government and government specific use cases, but this really does play across a broader market, whether you're in enterprise or other places. You're probably running into this as well. You're looking at CPU architectures that you've been using for the last decade or more, where between 2000 and 2018, a lot of the CPU growth has been kind of incremental and not significant. But as we look at 2017 to 2020, the CPU capability, things like AMD's CPU cores, their new chipsets, allow you to have a lot more horsepower in a per server footprint. The piece of this architecture that people aren't noticing is that when you bump up the performance in a per server basis as far as computing power, the one thing that hasn't changed is your underlying storage platform. And oh, by the way, there's an even growing amount of data that you're trying to bring into those CPUs to do that processing against. So Keith, maybe you'll dig into this a little bit more on the next slide, what's going on in the AI world.
Yeah, absolutely. And one of the things that's really driving these changes in the AI world is really the rise of GPU-based computing. We've all seen, CPUs evolve over the decades, but GPUs have really taken it to the next level. See, the primary difference between a GPU and a CPU is really the number of cores. When you look at a GPU, any individual core is going to only provide a fraction of the performance of a core of a CPU, but GPUs make up for that by packing a high density number of cores into an individual system. When you look at it, a CPU will have maybe 64 cores, but a GPU could have tens of thousands of cores. And by having a lot of lower performing, but thousands of cores, they're able to parallelize data and break that parallel data into multiple streams and really process them in parallel. So it's able to actually do things much faster. So when you have AI-based applications, when you have visualization, when you're looking at all of the data that's collected from the endpoints doing intrusion detection, really managing all of those different data points, the GPUs are able to look at them and present them and analyze them much faster. And that's really kind of changed the game for what we can do as far as finding threats, analyzing them, and uncovering them so much faster. And as we talked about, when you look at the costs associated with threats and intrusions, being able to identify them faster is incredibly valuable in any organization.
Absolutely. And Pavilion's really well positioned for this. I mean, if you look across the industries, obviously cybersecurity is front and center, but there are a couple vertical markets out there, whether it's artificial intelligence, whether it's media and entertainment, there are several of them that are all running into this similar challenge of dealing with the need for more computing and more data being brought in, and this real growing challenge of I/O. We see this, as well in analytics and research. And Pavilion is uniquely positioned to help solve and help customers with innovating into these challenging workspaces. We do this in 4 key areas. The first being performance. Obviously, you have to get the data in and out of that environment. Secondly, it's the density, being able to store enough data to make it valuable for these higher level applications, whether it's research or cybersecurity. The next part of it is, if I've gathered data, I've worked with some telecoms in the past on cybersecurity outside of the Fed marketplace, and they're scaling these solutions into petabytes and petabytes of data, storing not just 1 year's worth of data, but maybe 5 or 10 years worth of data. And so they need a scalable solution. And the last part of this is flexibility. So I capture the data today, I have a workflow set today, but 3 months, 6 months down the road, I get a new CIO and he needs it done in a slightly different manner. That's where ultimately a flexible system really helps. And Pavilion solves for this. And Keith, maybe you can dive into how we go about accomplishing that.
Yeah, absolutely. We talked about GPUs and how they're really impacting AI and the ability to detect threats due to their extreme high performance. But when you look at it, it really requires a complete system from processing to storage, which is why the CTO of NVIDIA has been quoted as saying high performance compute requires high performance IO. And Pavilion's uniquely able to deliver that. And we're able to do that because we have a fundamentally different architecture than the traditional storage systems you're going to see out there. Typically, when you look at any type of storage array, what you're going to see is you're going to see a traditional dual controller array. This is the same architecture that's been utilized in storage for decades, really. And each of those controllers is essentially a self-contained server, and they're clustered together to provide performance and redundancy. The challenge then becomes that individual server, that controller, is really the bottleneck that's going to limit the performance of any given storage array. Typically, a controller can really deliver the performance of you know, as it varies obviously, but as a rule of thumb, about 24 drives is going to be able to deliver the performance of that. So that's going to be the limiting factor, no matter how many drives you put in there. But Pavilion took a different approach. Pavilion didn't build its architecture like a server cluster. Instead, we built it like a network switch, the fastest thing in the data center. And because we did it that way, we're able to actually pack more controllers, more storage, more performance into a much denser platform. So it's providing a fundamentally different type of solution. And because we're able to do that, we can deliver much more. We deliver multiple controllers, not just two. We can put up to 20 controllers into an individual system. And we are able to do that because of that PCI switch-based architecture, which is a 6.1 terabit per second switch. We're able to pack up to 72 drives into an individual system. So 72 drives for up to over 2 petabytes of capacity in any given system, all powered by 20 independent controllers. And that's each controller is fully independent with its own CPU, OS, and networking instance. We're able to pack massive networking in there, up to 40 100 gigabit or 10 200 gigabit Ethernet or InfiniBand connections, all within a self-contained 4U chassis. And what that means is we're able to deliver greater performance, greater bandwidth, greater throughput with lower latency than any other solution out there. And a couple of things that really makes us unique is we are a cache-less system. When you look at a traditional dual controller array, one of the ways they achieve performance is they pack a bunch of either DRAM or SCM, such as Optane memory in there to try and create a tier of high performance cache. Well, we don't do that. The reason they do that is because the limitations of that dual controller array. Since we don't have that limitation, we're actually able to pass data directly through the drives. So we're able to deliver high performance without that extra cost and that really limiting factor of cache, because what happens is if that cache gets full, your performance can go right off a cliff. So we're not impacted by that. We're also able to provide extreme low latency data, and we're able to do that because we support RDMA. RDMA is effectively an ability to perform a DMA call, which takes data from storage and puts it directly into application memory without interrupting the CPU. We're able to do that over the network. So we're able to deliver extreme high performance with extreme low latency, not just within the system, but across the entire network. And the result is unrivaled performance density. And it's that density that is such a critical factor when looking at this type of storage solution, because I'm going to be honest, a lot of companies can meet our performance, but they do it with volume. They do it with racks of data. We have competitors that'll match our performance, but it quite frankly takes them 1, sometimes 2 full racks of data of storage to do what we do in a single 4U box.
That's a great point, Keith. And one of the things that I thought I'd start with on the cybersecurity side of things is high performance object. Now, obviously, I know what you're probably thinking. Object storage is really where I put, my old data, my cheapest, slowest performing log data. I put this out into an object storage solution. That's probably what you're thinking, but the question though I would pose back to you is really, how often do you have to go back and query against that data set? And how valuable is it for you to be able to get that data out quickly? Keith mentioned early on in our discussion that when we're talking about cybersecurity breaches, you're looking at the average time is something like 280 days, and that's a published benchmark. What happens when you're a telecom and you have to go back across 3 years or 5 years worth of data? Suddenly that slowest piece of storage architecture is one of the most important pieces of your architecture. And as Keith mentioned, excuse me, the density, being able to store this at the edge is very important for your collection of logs and processing. Imagine what your organization could do with a Splunk stack where you had 3 Pavilion chassis, as little as 12 rack units of your data center, and you had 24 effective petabytes of storage capacity. That might be 5 to 10 years worth of data, depending on the size of your organization. And oh, by the way, the really important part of this is when you need to go back and search those long tail data analysis for a security breach that happened in the past that's impacting you today, Pavilion can deliver 240 gigabytes a second of read performance from that object store. Pretty impressive when you consider that in the marketplace. Now,
That's exactly right, Keith. And I'd like to point out it's not just Splunk; it's really any big data application, whether that's Spark or Apache Drill or Elasticsearch. It's all of those cloud native applications, whether they're on-prem or off-prem.
Absolutely. And that's an interesting point, because we're not limited to just Splunk, but we're using that as an illustration. I know a lot of people are leveraging things like Elastic as an alternative. So depending on where you're at in your organization, in your security platform, Elastic and Splunk both are platforms out there that can take advantage of this. But Keith, I think you're going to dig into more of a Splunk use case and some of the flexibility that we offer, correct?
That's exactly right. In fact, let's go ahead and dive into that right now. So when you look at Splunk, Splunk as an organization really identified a few years ago that the ability to grow storage was being impacted by the way that people were organizing their data. What you had is you had a bunch of servers that were clustered together using some type of software, and each node in that cluster, that grouping, was how you grew your performance or your capacity. So if you needed additional capacity, you buy another self-contained server or some number of self-contained servers, and that's how you grew your capacity. But it's not really an efficient way to do that, because in addition to buying the storage, you're buying a whole server. You're buying memory, you're buying compute, you're buying networking, you're buying the management to install and organize and manage all of that. And as you do that, every time you add an additional node to that cluster, what you're seeing is some degradation in the overall performance of the entire system, because that software has one more additional thing to manage. And it's just not an efficient way to do it. So Splunk came up with something they call SmartStore. And effectively what SmartStore is a way to keep your hot data, the data that's just been created that you're going to be performing some type of analysis on, that all stays within your indexers. Your indexers, of course, being those Splunk systems that are going to actually identify, index, and run the analysis on the data. You're also going to keep a copy of the most likely to be added warm data. So it's frequently used warm data and your hot data are all going to stay within the indexer. Then what SmartStore is going to do is it's going to then copy your warm data and your cold data off to an S3 object store, theoretically, off into the public cloud or private cloud or hybrid cloud or whatever you happen to have. But it's going to go to some type of S3 object storage. So you're going to go ahead and keep your warm data and your frequently used data close to your processing, so you can analyze it, process it very quickly, but all your other data is going to be offloaded off to that S3. And this seemed to be a great solution. Enabled people to maintain performance. They still got to take advantage of low-cost scalable cloud storage, and everything seemed great. Well, it did solve the problem, but it only solved it at a point in time. What it really did is it kind of pushed it off, because what happened is as volumes of data continue to grow through log data, IoT, all the other things that are driving massive increases in the volume and variety of data that's being analyzed by these big data lakes, what happened is, well, the indexers got full again. And so they ended up having just the warm data, just the hot data cached locally on the indexer, simply because so much hot data was being created that they just couldn't keep it locally. So the result is all the warm data got pushed off to the cloud as well. And how that impacted organizations is, as they need to then perform analysis on that warm data, they're massively impacted by the cost of storing it on the cloud, because, well, it's very inexpensive to write data to the cloud. As a general rule, the cost of reading it back is extremely high. So it's going to be several times the cost of writes. And as a result, organizations get hit by these massive charges from their cloud providers, and the costs quickly spiraled out of control. The other thing that happened is performance was impacted, because while your hot data is still there locally for fast access, that warm data that you still need to perform analytics on, well, it's now going to be read back from the cloud from a remote object storage. So massive latency added in there as that data is brought back in. So costs spiraled out of control, latency went up massively, and that really impacted organizations' ability to effectively perform data analysis using Splunk. Now, Keith, is there a better way to do that?
Well, and great point, Keith. And one of the advantages is if you can, you want to accelerate, simplify, and save, right? I know that's a little bit of a tagline, easy to say, kind of rolls off the tongue, right? But in reality, if you're talking to the CIOs and folks that really want to have the answers quickly, they want to be able to have a robust solution that's good both for what they're doing today, but also down the road. This is where starting to take some of these design principles and apply them for workflows such as Splunk is so important. So again, if you're able to decouple the compute tier from your storage tier, look at the flexibility that you get. You can consolidate your server architecture and your storage platform, and now Pavilion can provide both your hot tier or your warm tier, and you can mix and match that design as you see fit. And as you know from the earlier slides, excuse me, got a tickle in my throat today. And as you can see, that we have the ability to deliver hundreds of gigabytes a second for at extremely low latency for block and that hot tier. At the same time, we can provide tens of gigabytes per second for even the warm tier. And again, high density really is important for some of these workflows when you're talking to a data center that's out at the edge, or maybe one of your data centers, which is footprint constrained, where you don't have a lot of room to scale out to some of these other solutions. And ideally, one of the things that you can do for processing at the edge, and I don't think we mentioned this before, is if you put the data, even in our system as an S3 object store platform on Pavilion, you can take advantage of cloud providers and burst in compute resources that mount into our system. And guess what you don't have to pay for? You don't pay egress charges in that model. And that's an interesting way to solve some of these hybrid cloud models where you're looking at, hey, there are a couple of cases where I want a lot of compute, a lot of resources to kind of search through data. Well, Pavilion gives you the best flexibility to do all of those things in a very high performant, small footprint type of design. Now, there's more to this. I think on the next slide, we talk about the next generation of what's going on in the marketplace. And we talked about the scaling of applications, but I didn't get into some of the challenges that people are running into. In high performance computing, the storage memory was always a key factor. How do I get processing in and out of the CPUs? How do I get processing in and out of the GPUs is even more difficult. And now systems that have GPUs built into them, they have a storage memory challenge where they can't flush the memory fast enough, particularly important for AI-enabled workflows and some of the tool sets that are kind of pushing the limits of what cybersecurity can do. There's more on this on maybe the next slide. So if you're not familiar with a company called Graphistry, it's one that you should familiarize yourself with. They've taken an interesting approach. So the typical cybersecurity analyst is set up rules that look through the logs to spot anomalies in a log set. And there are AI platforms there to help spot that as well. But Graphistry went at this from more of a visualization framework, which creates some interesting ways to spot these anomalies. So as you're looking at your data set in a visualized map, you can start to build that model so that it automatically recognizes the existing workflows. But where it becomes really interesting is when there's an anomaly, in a case where somebody's accessing something in an unusual pattern. And this is true a lot of times for hackers, where they're trying to create multiple hops to hide their access, their egress path for data in and out of your organization. Graphistry is one of those tools that can maybe help you with solving that. Or maybe you've got a developer who actually went through and added new code into production that maybe doesn't include an SSL security wrapper. And suddenly now you've created a vulnerability within your environment. Again, these types of tools are really powerful for securing your data center and shrinking that time window of when your system or your environment's vulnerable. Again, taking that 280-day window of vulnerability till you detect something, maybe shrinking it down to within hours, maybe even minutes, is really important for organizations today with a threat that's out there. Now, Graphistry ran into some challenges. This is a new way of processing data. And, they're talking about bringing in 23 gigabytes a second into the GPUs in order to do this processing. I'm excited to say that we've been working with Graphistry and some of these other really innovative companies for more than a year now in helping to push the limits of what's possible. Pavilion can deliver 90 gigabytes a second. So we can certainly push this data into a platform such as NVIDIA's DGX A100. But that wasn't enough. If we proceed to the next slide, you can see that even that has limitations. And can you spot the limitation here? You probably can. I don't have it fully illustrated, but the limitation in this design ended up becoming the CPU. The CPU was effectively throttling the Pavilion system at about 75 gigabytes a second. So NVIDIA saw this coming down the road. They recognized this before others in the marketplace. I read a blog on this about 3-4 years ago. I knew they were working in this direction, but we were working very closely with them on a new beta protocol called GPUDirect. And that's listed here as GDS. And what GPUDirect did was allowed you to get around the CPU, actually from the GPU, make direct storage calls. And again, that opened up that bottleneck and allowed the Pavilion system to get the data into those CPUs faster than anything out there in the marketplace. And it's been truly exciting working with both NVIDIA and some of these GPU-enabled applications like Graphistry to get that data in and solve that I/O challenge.
That's exactly right.
I was going to say you can share a little bit more. We're in a pretty select group when it comes to doing things like this.
That's exactly right. In fact, we supported NVIDIA GPUDirect at the first day of general availability. We are on their validated hardware list. But one of the things that really makes us unique is we're actually the only partner that supports both block and file level data using GPUDirect storage. There are different companies that might support one or the other. We're the only ones that can support both simultaneously. So depending on whatever type of data you have coming in, and one of the things that people are going to see is when they're getting data in, it's going to be in a variety of formats. You're getting log data, sensor data, IoT data, video, whatever it might be coming in. There's going to be some type of combination, most likely, of block and file level data. And because we have so many controllers, we can dedicate specific controllers to one or the other and really provide extreme high performance for all different types of data simultaneously. And that's one of the reasons we're able to really provide not just high performance, but extreme low latency. And our support of GPUDirect is in support of that. And the results is we have the most flexible high performance storage platform available. Just go into a few data points there. It's an extremely high dense platform, only 4 rack units per system. Now you can scale out across multiple systems if you need to, and you can do that for all the different data types, but each individual system is 4 rack units with over 2 petabytes of raw capacity, capable of up to 20 million IOPS, and extreme high performance of 120 gigabytes per second per system. And it's not just it's write performance. Write performance has become one of the most critical factors in data storage today. And that's because we have so much data being created by so many devices. All that data has to be written into the storage array. And as a general rule, quite frankly, most storage vendors don't even publish their write data. And I'm going to go out on a limb here. I'm going to say they don't publish it because they're not real proud of it. It's probably not very good. I just have trouble believing there's, marketing teams at all these big storage vendors going, wow, we have great performance. Let's not tell anyone. I have to believe that their performance isn't that great. And it's not. Typically, write performance on a storage array is 10 to 20% of their read performance, whereas we're able to deliver 75%. So huge performance delta there, and that is a direct result of our unique architecture. Because we are a cache-less architecture, we're able to provide extremely high write performance by passing data directly through to storage. And that's
I was going to say, Keith, that's really important for cyber workloads where you're doing data ingest streams. That's one of the growing challenges, whether it's cybersecurity log data, whether it's image capture for facilities security, things of that nature. Pavilion is uniquely able to help with some of those ingest data points where people can't get the data in fast enough. And we see that happening time and time again.
Yeah, that's exactly right. And the thing about all those data points being ingested is they're going to take different profiles. You're going to have block data, you're going to have file data, you're going to write it back out to object. Maybe you're going to store it locally as object. Pavilion is the only solution that can provide extreme high performance for block, file, and object data simultaneously. Typically, what you're going to see is quite frankly, most storage vendors are going to have a solution that supports, a couple of different data types. And the way they do that is it goes back to that dual controller architecture. You've got your software that's really built around one particular data type. We'll say file for the sake of argument. And then you're going to run another one on top of that. So then they slap object on top of it for an example. Well, because it's running one protocol running on top of another, performance for whatever that second protocol is tends not to be very good. Because we have 20 controllers, you can run any combination of those different data types on different controllers natively. So you'll have controllers dedicated to block and controllers dedicated to file, and controllers dedicated to object, all of them delivering high performance for that particular data type. So you're able to get high performance for all those different data types simultaneously. And we support pretty much any kind of data type you're typically going to use out there, whether it's block for NVMe or TCP and iSCSI. Maybe you're doing some type of file with NFS or SMB, or you're doing S3 for object. We're going to be able to support all those different data types simultaneously. And the result isn't not just that we're best in class performance for a data type, but it's best in every class. We have the highest performance density of any solution for block data, with up to 120 gigabytes per second of read and 90 gigabytes per second of write, but also going to be best in class for file, with 90 gigabytes per second of read and 56 gigabytes per write, and the highest for object, 80 gigabytes of read and 35 for write. And again, that's per system, and you can scale out across multiple systems using Pavilion. So it's not just performance density, it's flexible performance density. And that holds true across a wide range of use cases. Whether your applications are Splunk, like we've been talking about today, or maybe you're using Spark or Cassandra or SQL Server or whatever it might be, or whatever combination of applications it might be, Pavilion's able to deliver extreme high performance for all of those applications. So
well, I'll add to that. I frequently see Splunk running on top of VMware. We've got VMware integrations for VMware 7 where we can accelerate the data flow. At the same time, we can lower the CPU workloads on your VMware server infrastructure. Again, a lot of flexibility there. Thank you, Keith, for going over that, and I'll let you continue, but just thought I'd add that.
No, that's actually a really good point. We have a number of customers that are doing things like, SQL Server that they're running on VMware, something that historically people would never do. You'd want to run your databases right on bare metal. But because we deliver such high performance and low latency, we're accelerating those VMs, we're giving those CPU cycles back. So we have a number of customers running high performance applications, databases in a virtualized environment. So they're still able to get the performance they need while finally benefiting from virtualization, which has been one of the big challenges for those types of applications for years. And that's why when you're doing AI, you're doing ML, you're doing high-speed sensor ingest, you're analyzing that data to identify threats and intrusions and really stop them. We're one of those, really the only storage solution able to really enable that type of technology. And we're able to do it in a cost-effective manner to the business, ultimately enabling applications to run faster, perform more consistently, and scale larger. And with that, we'd like to go ahead and ask if there are any questions. If you do have any questions, please feel free to go ahead and enter them into the chat function. And it looks like we do have a couple of that have come in over the session. But if you do have any more, feel free to go ahead and enter them in, and we'll we'll address them as quickly as we can. In the meantime, let's see. This first question is, I see you have a CSI driver. Does this mean that you're able to also support DevOps use cases for block and object?
I can take that one, Keith. Absolutely. So a lot of DevOps users want a solution so that they can, not have to go to a storage admin to provision these types of resources. We absolutely have a CSI driver that automates that process so that developers can, self-provision, and we have an integration for that already in place.
All right, great. And so another question is, can I have a local S3 object store, or can I still tier to the cloud?
We support that as well. So we have the ability to operate as an S3 object store, but then we also support the ability to tier that out to, say a public cloud provider as well. So there is flexibility in that design. And like I said before, the more interesting way to do that is to actually burst compute down from the cloud and access our object store. Is a really interesting way to solve those types of use cases as well.
All right, great. And so the last question is, what is the real performance when you have hot data and object data on the same system? Lots of products support multiple data types, but performance of one of them is always terrible.
Would you like me to take that one, Keith?
Sure.
Sure. So with our architecture, we can split out the different workflows. We can actually separate them out so that you don't have spillage of one, the object store impacting the index or hot tier. So we absolutely can keep that separated so that you get you get the performance that you're expecting without kind of that problem of, hey, mixing and matching the data types on one platform. Because of the way that we separate things out, we do a great job at keeping those workloads separate, so you get the best performance for each one independently.
All right, great. All right, and I don't see any more questions coming in. So at this point, I'd like to thank everyone for joining us today. We did record this session, and this recording will be made available to you as soon as possible. And I'd like to thank Keith Ober for joining us. And if you do have any more questions, or if there's anything else we can do to help you, please feel free to visit us at pavilion.io. Thank you.
Thank you.